Well, today we're going to run through one of my pop tests. I've only got 10 questions, but I do provide the answers and some explanation at the end. And I said pause slides whenever necessary, but since I'm going through it with you, you don't need to pause the slides unless you just want to. However, I'm not going to do a lot of talking in the midst of each question until we get to the answer section. So let's get started. Engine sludge can bring about oil starvation that leads to bearing failure and can be caused by A. Frequent short drives, B. A stuck closed thermostat, C. A free-flowing PCV valve, or D. Any of the above. Question 2. EGR system failure can cause A. Lower cylinder temperatures, B. Ping or detonation, C. Higher CO emissions, or D. Any of the above. Question 3. A technician has been led by diagnostic trouble codes to investigate the reason for these fuel trim numbers. Short fuel trim 0, long fuel trim -27. Fuel filter may be restricted, oil contaminated with fuel, manifold pressure may be low, or oil pressure relief valve may be stuck. Question 4. If an engine is knocking due to rod bearing failure, it could be due to rust-clogged injectors, plugged EGR passages, a stuck oil pressure relief valve, or an overheated boost duct. Question 5. This is sort of like a technician A and B question, but I formatted it a different way. The first statement is an engine oil pump is a positive displacement pump. The second statement is engine oil pumps always spin at half crankshaft speed. Both are true, both are false, only B is false, only A is false. If you're like me, you don't really care for these questions because it's 2 questions in one and it requires a lot of thought. But I went ahead and did something like this anyway. Here's another A and B. A bad radiator can cause rust and corrosion, radiator cap can cause rust and corrosion buildup in a car's cooling system. The large pipe on a heater core is generally the heater core's inlet pipe. A, both are true. B, both are false. C, only B is false. D, only A is false. Here's another A and B. Most cooling systems call for a 50-50 mix of coolant and distilled water. B, a water pump driven by the back of the belt will always spin counterclockwise. Both are true, both are false. Only B is false, only A is false. Question 8. With cam and crank sensors, this is A and B, and a distributor, the timing can still be adjusted by turning the distributor. B. Injector firing frequency is directly tied to crankshaft sensor input. Both are true, both are false. B is false, A is false. Question 9. A no-start condition due to gas-fouled spark plugs is being investigated on a vehicle with these readings. So you can look at those readings there. Just pause the slide if you want to. So will it be a skewed Barrow sensor, a low or a weak TP sensor, an open IET sensor, or need to check more pins that aren't here? Question 10. With an assistant holding the key to the start position, the starter doesn't spin, but you read the voltage shown on the meter here. So what does this mean? Okay, now let's get into the answers and a little bit of discussion. Alright, I've actually talked about this enough to where nobody should have missed this question if you've been watching my videos. Engine sludge can bring about oil starvation that leads to bearing failure. Talked about it a little bit last week. Frequent short drives will do this because if you're not giving the engine, and I mean drives that are short enough so you don't give the engine a chance to warm up, that creates all kinds of sludge and carbon and everything else. It's one of the worst things you can do. One of the things that bothers me about used car lots is they move their cars around on the lot so it will look like they've got their inventory's in a state of flux, and usually they're starting the car and backing it out and moving it down to the other end, and then they start the car and move it, and they're just moving them short distances without letting them warm up. And that's a terrible way to do the car. You know, if you've are looking at a car at a used car lot or at a used car dealer or whatever, you need to ask them, how long have you had this car and how many times have you moved it? You know, if it's been there for a year and they've moved it about 3 or 4 times a week for the year, I can guarantee you that thing is going to have some sludge in it that you don't want to have to deal with later. A stuck closed thermostat won't cause that because that's typically going to make the engine get too hot. That won't cause engine sludge typically. A free-flowing PCV valve, the opposite would cause sludge if the PCV system wasn't working at all. And so any of the above is obviously the wrong answer because 2 of those answers, from my perspective, are wrong. Question 2, EGR system failure can cause lower cylinder temperatures? No. Ping or detonation. The reason for that is, now it depends also, you might say there's a caveat here, how is the EGR system failing? Does it fail by, with the valve sticks open, you're going to get a rough idle that way. If the valve sticks closed, you're not going to get any exhaust gas recirculation, and since that is actually meant to cool the combustion chamber a little to prevent the formation of oxides of nitrogen, you can get pinging or detonation if the EGR valve is not working, but you won't always. I had one instructor that told me that basically you would burn a hole in the top of a piston on some of the platforms he was teaching about if you disable the EGR valve, and I have never seen that. I was just going by what he said, about that particular one. But the EGR really needs to be working. It won't be higher carbon monoxide emissions because that comes from a slightly rich mixture, then it won't be any of the above. Technicians have been led by DTCs to investigate the reason for these fuel trim numbers: short fuel trim 0, long fuel trim -27. The fuel filter is not going to be, the restricted fuel filter is not going to cause it to subtract fuel. It's basically detecting a rich condition, and that's when it's subtracted fuel, so the oil contaminated with fuel. Here we got manifold pressure may be low, oil pressure relief valve may be stuck, so it's going to be oil contaminated with fuel is what it is on this particular one. If the engine's knocking due to rod bearing failure, it could be due to a stuck oil pressure relief valve. Now, I made a little video showing how the oil pressure relief valve works. The oil pressure, the oil pump, and in the next question we're going to talk about that, is a positive displacement pump. But if it's wide open, you won't have any pressure because you have oil pressure because of the relief valve. If the relief valve sticks closed, if it can blow the oil filter slam off the car if the oil pressure relief valve sticks closed. If the oil pressure relief valve sticks open, lose oil pressure and things get destroyed. So you need an operational oil pressure relief valve. I did an engine one time when I was working at a truck shop. It was a gas burner, and it had low oil pressure when I was done, even though the bearings were all new and all that. And so we didn't really price these people out an oil pump. There was really nothing wrong with the oil pump, but I detected when I took the oil pump apart that the oil pressure relief valve spring was kind of weak, and so the oil pressure was squeezing that spring too soon. So I took and put some little washers underneath that spring to tighten it up, and the oil pressure normalized after I did that, after I put the oil pump back on there. That was, my gosh, that was in the 80s, in the mid 80s. An engine oil pump is a positive displacement pump. I've already talked a little bit about that. If it turns and there's oil there, it's going to move that oil somewhere. I used to take an oil pump I had with it, had the rod that would spin like off the bottom of the distributor, and to demonstrate to my students this oil pump, I would stick it in the pickup tube in a thing of oil, and I would spin that thing with my fingers one time, and it would shoot oil halfway across the shop. It's amazing what those things will do. A bad radiator cap can cause rust and corrosion buildup in a car's coolant system, because if it just lets air come and go, you're going to get a lot of oxidation in there. It depends on how the radiator cap is bad. That's another caveat. The large pipe on the heater core is always the core's outlet pipe, because if that's the inlet pipe, you're going to bust the heater core a lot of the times, because the bigger pipe needs to be the one coming out so that you don't have a lot of pressure. So it's false. Most coolant systems call for 50-50 mix of coolant and distilled water. That's true. Most of them do. Occasionally you'll see some Asian make that won't be like that. B, a water pump driven by the back of the belt will spin counterclockwise. I'm going to let A be true because it's in most coolant systems, but the water pump is liable to spin anyway, because the reason I'm saying that is if you've got something like a Mitsubishi or a Honda Civic where the engine is in there backwards, then the engine doesn't turn in the same direction as the engine in a car that with the engine turned the other way. So all bets are off on that. With a cam and crank sensors in a distributor, the timing can still be adjusted by turning the distributor. There's only one time I've ever seen that on one vehicle. The rest of the time, if it's got a crank sensor and a cam sensor, even if the cam sensor is in the distributor, you're not changing that timing when you turn the distributor. All you're doing is changing the rotor alignments, and it can actually be a problem. So you cannot turn the distributor and set the timing, but you can set the rotor alignment. And you know, there's basically scan tool procedures on Dodges and Chevys. I've talked about that before. A is false. Injector firing frequency is directly tied to crankshaft sensor input, but there will be some extra injector squirts in there when you're giving it the gas that does the same job as the accelerator pump, right? Okay, question 9. A no start condition due to gas foul plugs is being investigated on a vehicle with these readings. That's going to be an open intake temperature sensor. Now, when that will typically happen is if the weather is warm and you're starting, it's going to start perfectly every time. If the weather is cold, all of a sudden, if you have a cold snap, these skewed IET reading that you see right here is going to cause that thing to overfuel. Now, the reason that's like that, you're looking at the enhanced room. If you look at the OB2 room, the generic room, you're going to see 40 below. But what the enhanced room does is it substitutes for the algorithm purposes this reading here. It'll do this on a Dodge, and it does it on some of the other ones too. And if it believes the engine coolant is 45 and the intake air is 101, it's going to overfuel the stew out of it. And I've seen that foul spark plugs on vehicles that were doing just fine until there's a cold snap. This right here is an interesting little thing here, and you don't see this a whole lot, but you got on this one, you got high resistance in the solenoid secondary contacts. When this copper washer slaps against that set of contacts right there, you should have practically no voltage drop at all right there. But on this one here, you're showing 9.8 volts, and that will burn the starter up. So a bad solenoid can burn up a starter, and so this is gonna be a real short video today. I hope you guys really enjoyed it. I hope you got something out of it. Let me know how you did on the test, and I'll talk to you guys next time. And hey, let's be careful out there.